Hello everyone, welcome back. So in this video I'll be explaining about software and software engineering principles. So this is your actually the first module of software engineering and project management. So what are the things we will be considering under this software engineering? So we will come up with the nature of the software. So what is the naturality of the software which is present? So software actually takes on a dual role. So it is a product at the same time and also a vehicle for delivering a product. So like let us remember the definition of software like this. So it is a product and it is also a vehicle for delivering a product. Now, as a product, it should deliver the computing potential embodied by a network of computers that are accessible by local hardware. For example, web browser means the software is nothing but basically a product. So a product means it should be able to solve a problem which is being faced by the user. So it delivers the computing potential embodied by network of computers. Means network of computers align together and making a product, whether it resides within a mobile phone or operates inside a mainframe computer. As the vehicle, it is used to deliver the product. Software acts as the basis for control of the computer. That is the communication of information. Now, what is software? So basically, these 3 points you are supposed to remember. So you can actually, there are two definitions with respect to software. So one definition is it is taking a dual role. So it is a product at the same time vehicle for delivering a product. And the another definition is the software is collection of three important points. That is your instruction, data structure, and documentation. So what does this instruction stands for? So instruction stands for computer programs. For example, if we consider an algorithm is considered as step-by-step sequence of finite instructions, isn't it? So when we are considering instructions, so it is a computer program, so that when executed, it is going to provide some desired features, functions, and performance. It also aligns with the data structure. So what is data structure? So data structure is a way of organizing and storing the data in a computer. So in what format we are going to store and access the data in a computer, the study of that we are going to tell it as data structures. So the data structures also play a huge role in enabling the programs to adequately manipulate information, and documentation that describes the operation and use of the programs. Means till now from the start what things you have done in the software. For example, when you are building a project, whether it can be micro project or mini project, when you are building that, we are supposed to prepare a report after building the software product and when it is running successfully. So that is what it stands for, documentation. That report stands for documentation. So in that report I'm going to tell one from when I have started the project, from then till the last date, means till the end product, and until I achieve the end product, what were things I have achieved. So all those things in form of English sentences and few pseudocodes and also a few pictures. Using these things, I'll be preparing a report. Now, software, it is developed or engineered, it is not manufactured in the classical sense. Yes, we are telling software it is developed or engineered, it is not manufactured. The moment I tell manufacturing, it will be related to the hardware, means it is related to the hardware, not the software system. So software, it is always developed, means both activities require the construction of a product, but the approaches are different. Software doesn't wear out. This term wear out will stand for hardware substances, not for software. Software is not susceptible to the environmental maladies that cause hardware to wear out. Although the industry is moving toward component-based construction, most software continues to be custom built. Now, software components should be designed implemented in such a way that many of the components can be reused in many different programs. Means one component of one software should be able to reuse it in the another software. Now, this is the graph which you are able to see. So this graph stands for wear versus deterioration curve. So this is very important graph with respect to your SEM exam and also your internals. They can ask this question. So write the graph between the considering failure rate on y-axis and time on x-axis. What is the difference between the hardware and software? That is the wear versus deterioration. So wear stands for hardware and deterioration stands for software. So what are these? This is the idealized curve, and actually what is happening, so this is the change and increased failure due to side effects. So this is the idealized curve which we expect in all cases, but the actual one is this one which is happening in all circumstances. Now, failure, wear versus deterioration. The graph description is being shown here. So, failure rate curve for software should take the form of idealized curve. That is what we expect. So, whenever the product which we build, so here we will expect everything to be in the form of idealized curve. Means of with as and when the time goes, means the amount of time increases, there should be less amount of failure. So undiscovered effects will cause high failure rates early in the life of a program. Errors are corrected and the curve flattens. Software doesn't wear out, but it does deteriorate. So during its life, software will undergo change. As changes are made, it is likely that errors will be introduced, causing the failure rate curve to spike. Means as and when time passes, software will undergo many of its changes. Many of the components will undergo the changes. So as and when changes are made, it is likely that errors will be introduced, causing the failure rate curve to spike. Now, before the curve can return to the original steady state, another change is requested, causing the curve to spike again. Slowly, the minimum failure rate level begins to rise. That means the software is deteriorating due to the change. When a hardware component wears out, it is replaced by a spare part. But there are no spare parts for software. Spare part is nothing but the additional component. Means suppose if a component of a bicycle gets gone, means we'll be manufacturing many other products of the same type, right? So we will replace that with this. So like that, it is with the hardware but not with the software. Now, software application domains. So coming to your software application domains, there are basically seven types of software which are able to see. Generally, when you go with the operating system, the study of operating system, you will come across only with two types of software. That is a system software, another one is your application software. But in reality, we are actually having seven types of software. So one is a system software. So system software means that is a compilers, editors, operating systems, all those things. Means collection of programs written to service other programs. Now, application software means you in your system it refers to some specific application. That is what you mean by application software. For example, MS Word, MS Excel, like MS Office, and a few other tools which are present. So those and all stands for application software when you are considering with the software thing, or else real-time manufacturing process control, like that. Basically, it stands for one component. Now, engineering or scientific software characterized by number crunching, that is, there are large number of algorithms. Applications range from astronomy to volcanology. So here the few words are very very important. So remembering these words, applications range from astronomy to volcanology. So volcanology, in the sense, it basically tells it is a huge one. It is a mass number, like that. Embedded software. So embedded software means reside within a product and it is used to implement and control features for the end user and for the system itself. Means you are doing the changes, you are going to implement in such a way that it is used to control the features for both the end user and as well as for the system in which you are building. Example, digital functions in an automobile such as fuel control, dashboard displays and braking systems. Coming to your product line software, so it's designed to provide a specific capability for use by many different customers. For example, spreadsheets, MS Excel, we all use it, right? Like that, financial applications, personal and business, computer graphics, everything. We use these tools for our own purposes. Web or mobile applications, wide array of applications which encompass both browser-based and mobile-based. That is your desktop-based and mobile-based versions. And now AI software. That is it is going to use your non-numerical algorithms to solve the complex problem. Now, software. So there are actually four things. One is the open world computing, ubiquitous computing, net sourcing, and open source. Now, open world computing means it is distributed computing. Ubiquitous means basically it is available everywhere. So ubiquitous computing in the sense it is wireless networks. Means basically wireless networks in the sense there should not be any connectivity. Even without connectivity also the network should exist. So that is what that can be the best example for ubiquitous computing. Knowing the meaning of ubiquitous computing will help you to map why the example of wireless networks is being written. Now, coming for net sourcing, the web as a computing engine, and coming for your open source, it is a free source, open to the computing community. Now, legacy software. Coming to your legacy software, you are supposed to understand that older programs means the programs which are developed decades ago. So those programs are actually called as legacy programs, or those type of software is called as legacy software. The increase of such systems is causing headaches for large organizations who find them costly to maintain and risky to evolve. Since those Softwares are developed decades ago, it is very difficult to maintain them and it is risky also. So legacy software will be of a poor quality itself. Now legacy systems, it will support core business functions. Means legacy software, it is such a software where it will contain only the basic things which is very necessary, but there won't be any advancements in that. But does it mean that I am supposed to avoid the legacy software? So no, the answer is no. I'm not supposed to avoid, I'm not supposed to neglect the legacy software. I have to consider that. If the legacy software meets the needs of its users and runs reliably, if it isn't broken and does not need to be fixed. Why it must change? Means the software why it must be changing. So as and when number of features increases as and when time passes, more number of changes are required because even technology keeps evolving. Since technology keeps evolving, software also must be enhanced. So software must also be enhanced to implement new business requirements. Software must be extended to make it interoperable with more modern systems. Software must be re-architected to make it viable within a network. Now, changing nature of software. So coming to your changing nature of software, you should remember these things. That is your web apps and mobile applications, cloud computing also. Now, coming to your web apps, basically these are network intensiveness, concurrency, unpredictable load, performance, availability, data driven, content sensitive, continuous evolution, immediacy, security, aesthetics. Now, coming to your network intensiveness, a web app resides on a network and must serve the needs of a diverse community of clients. However, the network it might be, like whether so many people are going to log into your app at the same time, that doesn't matter, but it should serve various community of clients. Now, concurrency, a large number of users may access the web app at one time. For example, if you can take any e-commerce application. So giving an e-commerce application will be a better one to make you understand. Example, Amazon. So we don't know when we take Amazon application, we don't know at which time how many people are going to come and access the page. So considering a random time, at least if you consider in the whole world, at least minimum of 30 to 50,000 people will be using the Amazon page. Not just 30 to 50, it might be more than that also per second. If I'm considering per second, if they're making any transactions, it might be more than that. So concurrency means if one person is able to access at some stipulated time, even the 30,000th person also should be able to access that web app at the same time. Now, unpredictable load. Number of users of the web app may vary by orders of magnitude from day to day. We don't know at what time how can be the load, so we should consider that, we should keep in mind, and we are supposed to build the software such that even if the load increases, it should be able to serve the queries for the users. Now, performance. Now, if a web app user must wait too long, he or she may decide to go elsewhere, like this. So availability means all the expectation of 100% availability is unreasonable. Users of popular web apps often demand access on 24 bar 7 into 365. The 24 bar 7 into 365 means all the time. All the time they expect the availability of the web app which is being built. Now, coming to a content sensitive, the quality and the aesthetic nature of the content remains an important determinant of the quality of the web app. Now, aesthetics is nothing but the look which you are able to think all about with respect to a web app. So, it must be in a proper format as well. Now, coming to your security, because web apps are available via network access, it is very difficult, if not impossible, to limit the population. Immediacy. Now, the compelling need to get software to market quickly is a characteristic of many application domains. Now, web apps often exhibit a time to market. So that can be matter of few days or weeks. Remember one thing, whenever you are building a product, so coming under time to market will be a boon for you. Because hello. Coming to your immediacy, so the compelling need to get software to market quickly is a characteristic of many application domains. Web apps often exhibit a time to market that can be a matter of few days or weeks. So that I have already been told to you. Now, coming to your continuous evaluation. Now, unlike conventional application software that evolves over series of planned chronologically space releases, web applications also evolve continuously. So these are a few theory points. So out of these, you can remember around 4 to 5. It would be more than sufficient because you are having even other topics also. So with this note, I'll be ending the video. So keep sharing the video like this to everyone. Thank you.